Imagined Speech Decoder is a research project initiated to investigate the possibilities of restoring speech in speech-impaired individuals. Let us dive deep into the problem at hand. You may know these famous personalities. What do they all have in common? They were all speech-impaired. This is known as aphasia, which has a higher rate of incidence as the numbers show. Our target group are the subjects who cannot speak but have their brain functionalities intact. This is how our brains process speech. Wernicke's area understands what we hear. The Broca's area produces speech. Both these areas are connected by the arcuate fasciculus. Functional near-infrared spectroscopy, or fNIRS, is one out of the two modalities investigated in this project. It uses near-infrared light to estimate the cortical hemodynamic activity in terms of changing oxyhemoglobin and deoxyhemoglobin levels which occur due to neural activity. For this, it uses two infrared light sources at two distinct wavelengths, and the variations in the reflected wave is identified by photodiode. A prototype fNIRS acquisition device is fabricated due to the unavailability of a commercial device. Several optodes or sensing units can be connected to a central controller. Our optode design becomes unique because it has a compact, standalone design and has a digital locked-in amplifier integration for better signal acquisition. The designed optode is circular and made smaller for better placement. It sports functionalities for signal acquisition, processing, current control, and communication. Central controller works as a hub to connect several optodes together using SPI protocol. Even without it, the optodes can individually communicate with the host device. The prototype was verified when the subject was engaged in Valsalva maneuver and mental arithmetic tasks. The following results were obtained in the Valsalva maneuver. A variation in oxyhemoglobin and hemoglobin levels can be seen in the results. The prominent modality investigated in this project is the classification of vowel phonemes using EEG signals. This is due to its high temporal resolution than fNIRS and non-invasiveness. The proposed methodology follows the pre-processing of EEG, feature extraction, and classification. The study was done as both binary and multi-class classifications and analyzed in both subject-dependent and subject-independent learning scenarios. With the ethical approval granted from the University of Marachewa, we managed to collect a dataset for 6 and 16 channel montages with 120 trials each from 33 subjects. The experimental paradigm contained both visual and auditory stimulus. The relatively low accuracy is due to insufficient information of the EEG domain for imagined phoneme classification. The results obtained using the collected dataset are higher than that of the open-source dataset, proving superiority in the proposed experimental procedure. There exists a high subject-dependent nature in phoneme imagination. A paper is also submitted on the EEG paradigm, and another is being written for the hardware implementation. The proposed method obtains significant results using a reduced electrode montage of 6 channels for the classification of imagined phonemes in comparison to the related studies using machine learning. That is higher than the existing works using machine learning in EEG modality. We have achieved all elements of the work breakdown structure, successfully concluding the project Imagined Speech Decoder. For future collaborations and further inquiries on the project, feel free to contact us. Thank you for watching.